Good day to everyone. My name is Babajide. I am honored to stand before you today, and I want to thank the organizers of this conference, the Chambers of Civil Engineers, and also I want to thank my supervisor, Associate Professor Mohamed Ali Musibatin. Thank you all. Introduction. Throughout history, concrete has emerged as one of the most utilized building components. According to Pascal 2017, it stated that after water, concrete is the most utilized on Earth. The ever-increasing volume of industrial waste is the root of many environmental burdens and problems. In recent years, waste materials such as coal ash, glass, steel slag, copper slag have increased rapidly. These wastes are primarily generated from industries and domestic waste, and the possibility of contaminating natural resources such as air, water, and sand constantly increases. It is required to help to improve concrete efficiency through the use of waste-related materials, and also to prevent river sand and valuable areas from pollution dump sites. The use of waste-gas powder and coal bottom ash in concrete industry will help to mitigate the environmental difficulties that are arising as a result of its presence. The problem statement is basically due to low income and also high numbers of underdeveloped countries, which they live in low quality housing. Some people reside in ramshackle housing made of waste materials, which they cannot afford the construction component of these materials. However, the most expensive materials used in concrete is cement, and the demand is globally increasing. When cement is produced, carbon dioxide is released during the mobility and processing method. It is consequently measures must be taken into consideration so that carbon emission by using greener building materials can have less impact in the environmental in terms of production and transportation. Here are my research goals. One, the evaluating the impact of waste-gas powder and coal bottom ash in fresh concrete for different waste binder ratio, and also to ascertain how waste gas and coal bottom ash can be used or can affect the development of hardened concrete. Also, to quantify the performance of glass powder and coal bottom ash as an alternate replacement of cement while using specific proportion. These are various researchers who have actually touched or worked on waste-gas powder and coal bottom ash. It is noted that most of these researchers reported that incorporating waste-gas powder and CBE improves mechanical properties of cementation composites. And also, it may stated that waste-gas powder overperformed with CBE. Okay, sir. I move to my materials. My materials used are waste-gas powders and coal bottom ash. These are bottles generated from different houses, hostels, and in Lake Scotia. And also, this is the process. These are my waste-gas powder, the procedures, and these are ICPs. Coal bottom ash. The coal bottom ash used here is a lignite coal, and the percentage of lignite coal is 25 to 35%. This is my nomenclature of my results, 20% optimum percentage. My result and discussion. I have different results which are based on the flowability or workability, also and the mechanical properties. I move to my flowability. It is stated that 20% of waste glass powder increase in workability, which means that it might be due to the lightweight surface area of glass powder that increase in flow. Also, my compressive strength. My compressive strength has an higher increment in compressive strength of waste glass powder, and it's increased in early stage. While also my CPA partially reduces, but at 28 days there's an increment. Those are my figures over there. I move to my durability test. Absorption of water. It is noted that 20% of CBA absorb water, but 20% of waste glass powder, reduces in water absorption. Fire resistance also is a part of the durability test, in the sense that at 20, there's various tests I did in my fire resistance at 20 degrees Celsius, 40 degrees Celsius, and 600 degrees Celsius. And at 200 degrees Celsius, there's an accurate strength that is strength improvement. Also, at 400 degrees, it's deteriorated a little bit. For 600, it really reduces. That's because of the attribute of the breakdown in CHL and dehydration of carbon dioxide due to the expansion of the aggregate of this temperature. In my conclusion, it is noted that a waste glass powder has been determined as the best for 20% replacement with a level of 1.5% of additive and also a constant water bender ratio of 0.35. And in my conclusion, flowability observation shows that workability of these samples enhanced as the glass powder content replacing cement expanded. And also, the compressive strength explain that development of strength increases at age at a fixed water cement ratio of 0.35. Substituting 20% of cement with the waste glass powder enhance the compressive strength. Furthermore, in conclusion, based on my analysis and conclusion, it is determined that waste glass powder and CBA plays an advantageous effect or important in terms of structural and long-term strength. And also, CBA can also improve overall performance of cement-based mortar. My recommendation, it is important to combine glass powder and other cementitious materials as a partial replacement of properties and as a partial replacement of cement and also fine aggregate. Also, in my research, I also explained that to conduct a long-time research, you can also use waste glass powder and go bottom match in steel construction. So, addition of this research will be conducted along line to enable us to utilize bottom ash and in addition of implementing bottom ash into building structures. These are my references. Thank you all for listening.
Thank you.